Let us discuss definition of Cauchy sequence. See, Cauchy sequence we have already seen in F5 BSc for a real number, sequence of real numbers. Okay, so let us see definition of Cauchy sequence in a metric space XD. So if we have a metric space XD and sequence xn in X is said to be Cauchy, so the same definition which we have already studied for real numbers. See, what is it? For given epsilon greater than 0, there exists n belongs to set of natural number such that d of xn xm less than epsilon for all n comma m greater than or equal to capital N. That means what is happening here, distance between two terms of sequence is less than epsilon. That means that is reducing. In case of convergent sequence, what we have a fixed target and all terms of sequences are moving towards that fixed target x. So that means we say the sequence is convergent and converges to x. But see, in case of Cauchy sequence, there is no fixed target. Okay, so the points are not moving towards a fixed point. The concept is distance between two points is reducing. Getting? So here we have a more distance and the distance is reducing side. And finally they will gather together. Okay, so this is a concept of Cauchy sequence. Okay, so there is some relation definitely between Cauchy sequence and convergent sequence. Let us discuss that relation also. Make a screenshot of it first, then we will go further. Now we will prove that every convergent sequence is Cauchy sequence. Okay, see here I have considered one matrix space XD. I have taken one sequence Xn which is convergent sequence and converges to X. So we have to prove that yes, this sequence is Cauchy sequence. Obviously using definition we are going to prove. So for that purpose we need to take one epsilon first. Let epsilon greater than 0 be given. So I am going to use the definition of convergent sequence. So therefore there exists a natural number such that definition says d of xn x less than epsilon for all n greater than or equal to capital N. I will call it as inequality or statement number 1. But see, I am going to do a small adjustment here. Instead of epsilon, I will take epsilon by 2. See now, for nm greater than or equal to capital N, I am going to consider d of xn comma xn. Okay, so our target is to prove that sequence xn is a Cauchy sequence. That means we have to prove that d of xn xm is less than epsilon. Okay, so here I am going to use triangle inequality. So by triangle inequality, what can we write? This is less than or equal to d of xn x plus d of xxn. Getting, I have added one point x here, which is same as d of xn x plus d of xmx. If you interchange, then also distance between them will be same. But see, this is less than epsilon already we have got. So this is less than, epsilon by 2. This is also less than epsilon by 2, since here we have mentioned m is greater than capital N. And this is true for all natural numbers which are greater than capital N. If you have p greater than capital N, it is true for p also. If it is t greater than capital N, then it is true for t also. So here is also m is greater than capital N. So for m also we got the same inequality. This is equal to epsilon by 2 plus epsilon by 2. So therefore d of xn xm, we had started with this one and we finally proved this is less than epsilon for all nm greater than or equal to capital N. This is definition of Cauchy sequence. So therefore what can we write? Therefore sequence xn is Cauchy. So we had started with a convergent sequence and we proved finally that it is Cauchy. So therefore every convergent sequence is Cauchy. Make a screenshot of it. After that we will stop. Thank you. Bye bye.